today let's try to solve another DP problem. So this is a DP max profit problem. So there are a lot of such problems in Leetcode, and this one gonna be a little bit harder than other problems. So it is the maximum profit in job scheduling. So we have a job scheduling like this. We have a start time and end time. So for example, the start time is 1, end time is 3, and we also have a profit which is 50. And we also have other tuples like 2 to 4. From 2 to 4, the profit is 10. So from 3 to 5, so this is 3, this is 5, the profit is 40. And the last one, from 3 to 6, the profit is 70. So in this example, as we can see, that the maximum profit is from 1 to 3, 3 to 6, which is 50 plus 70, that is 120. And we cannot find a bigger profit than 120. So how should we solve such problem? We're gonna first check the variables like the start time, end time, and profit. So the length of the start time equal to the end time equal to the profit. Yeah, it means we can do something like a tuple. We can put those 3 variables inside a tuple, and we can also check the start time and end time. So it is more than 1 and less than or equal to 10 to the power of 9. Yeah, so it means we can use dp, but we cannot use the time as the dp variable because 10 to the power of 9 is too big. It must be time limited exceeded. Yeah, if it is a time limit exceeded, we have to optimize this dp problem. So we cannot use the time directly because the time is 10 to the power of 9, but we can use the tuple. I mean inside the tuple of start time, end time, and profit. Why we can use this to solve it? Actually, it is the same. Let me make a drawing. I think it's gonna be easier to understand. Yeah, so if it is just time, if we can use time as a DP array, we can check each of the points as the time. It's gonna be really easy. Yeah. So for example, at any time, this is time t. So what is the maximum profit? Yeah, so the DP array ft would be equal to ft minus 1 because there are always 2 decisions at each point. If at this point t, so this t is just add time. So this t is just add time. Yeah, at any add time t. Yeah, so this t is just any add time. At any add time t, we can have 2 decisions. One decision is we will not take this job. So it will be ft minus 1 because we will take the maximum profit. So the profit. So ft just means the profit at any add time point at any time. Yeah. So if at any add time t, yeah, so this t means at any add time, what is the maximum profit? If we will not choose to have the job at the add time t, so we're gonna take the previous one. It's gonna be ft minus 1. So what if we take this t? So it would be, yeah, the maximum ft would be the maximum of ft. Yeah, but this ft equal to ft minus 1. So if I don't use this formula, I can use this ft minus 1 directly. So it would be ft minus 1 and plus. We need to plus the profit. Yeah, but this profit would be enumerate all the possible results. Yeah, so this t is just at any add time. This is just add time. Yeah, so this is the decision. We will not choose this add time. But what if we choose this add time? So we must know there must be some start time. It can go to this add time. We are not sure. This is the start time. There must be some start time. Yeah, let me just make it clear. Yeah, so there must be some start time. It can go to this add time. We don't know how many. There may be many start time. This is maybe S1 and this start time S2. It can go to this add time. And this is the profit. For example, it may be P1 or P2. We have to enumerate all the possible cases. So it would be P plus this F with the start time. Yeah. So this is the base case. If we're gonna use the time, we're gonna use we're gonna check each point, all the points of the at the time one by one. But this at the time may be 10 to the power of 9. It would be a very big number. Yeah, but we have to check all of them. Yeah. Now we will not use this solution to solve it because that is impossible. But we can sort the array according to the add time. Yeah, so for example, we can sort the array according to the add time. So first of all, we're gonna put the add time and start time and profit inside a tuple. So we have the tuple array because the length of the add time equal to the length of the start time equal to the profit. So we're gonna put it inside a tuple. So inside the array, now we have the tuples, and we're gonna sort the array according to the add time. Yeah. If we sort the array according to the add time, for example, this is E1, and this is E1 add time 1. Yeah. So if this is E1, maybe this add time is E2, and this add time. Yeah, we will not take care of the start time at the moment. This add time maybe E3. We have another add time maybe here. Yeah, because we've sorted it according to the increasing order, so it will be like this. So there is another add time E4. So if there is no overlap for the start time, for example, if this is E1, this is S1, this is okay, there's no overlap. Yeah, we're gonna just accumulate all the profit. Yeah, if this is S2 to E2 because there's no overlap. Yeah, and we also have a profit. Maybe this is 5 and this is 4, so it is 5 plus 4. It is okay. So for this S3, maybe this is 6. So 5 plus 4 plus 6, it is 15. But what if this start time is at some other places? So for example, let me make, if the last one, the start time may be here. So for the last one, this is the add time, and here is the start time at 4, and this one maybe have a profit of 100. Yeah. So this means for the normal case, it is okay. Yeah, the profit at each add time. So we're gonna accumulate. Yeah, we can accumulate all the cases. But what if there is an overlap? So this start time is just at this position. So at this position, what is the maximum profit we need to consider? Yeah, we still have two decisions. We will not choose this add point. So it's gonna be F. If the position is I, this position is I, it is Fi minus 1. This means we will not choose it. So it is Fi minus 1. It means it is just before this E4. It means it is E3. It is 6 plus 4 plus 5. It is 15. But what if we choose it? Yeah, if we choose it, we're gonna have a profit. We're gonna take the maximum of Fi minus 1 with 100 because 100 is the profit, and we're gonna take another one. And which one we need to take? Yeah, we need to we cannot take this one because it is overlap, and we cannot take this one also because it is overlap. We have to take this one. The add time should be E1. Yeah, but how can we take it? We can use a boundary search to find the positions. Yeah, as you can see, we cannot take those two because there are overlap. But we can take the first one. Why we can use the binary search? We can use a binary search to find the positions because this is an array. This is a sorted array. This is add time, start time, and profit. It is already be sorted. So we can use the binary search to find the position. Basically, we want to find a start per. We want to. Yeah, we want to. Let me think. We need to. Yeah, we can use the start to. Yeah, we can use the binary search with the start position because for this one, while we loop through this one, we have a S4. This is the start. This is the start point for the last one. So we're gonna check if we can. Yeah, we can find this E1. How can we find this E1? We can use a binary search to find this E1. I'm gonna program first, and while you come to here, I'm gonna explain it because there's still some tricks to explain this area. So for example, we have the 100, but we need to plus this 5. But how can we find this 5? We're gonna use a binary search. Binary search basically it is a tuple array. So we can use a binary search to find a position S. We can use a binary search for this S4 inside this array. So inside this array, we're gonna find a position which is more than and for the add point which is more than it is here, which is more than and equal to S4. So it should be E2. But of course, E2 cannot be the result. It has to be -1. If E2 -1, it must be E1. I mean, the position before it must be E1. Yeah. Now we're gonna use this 100 plus the profit from E1. It is 5. So it's gonna be 105, and this would be the final result. Yeah. Let me just start coding, and it will be more clear to understand. And then I'm gonna go back to explain why it is like that. Yeah, so for this problem, I'm gonna prepare a tuple. So the tuple will be the jobs. So it would be sorted according to the add time first, and then start time and profit. So this is a tuple, and the jobs have already been sorted. Now I'm going to check the length of the jobs. And I'm gonna prepare the DP array. It's gonna be 0 times, as always, it will be according to the jobs. This one will not be according to the time. Otherwise, it will be time limited because the time is too big. So I'm gonna use the jobs array. Yeah. So I'm gonna use n-1. Because for the first position, the F0, it is just a dummy place for me, easy for me to calculate. Actually, it is starting from F1 because this F0 is just nothing, but it is easy for me to calculate because you can check why because I'm gonna loop through from 1 to n-1, n plus 1. That is why I'm gonna prepare a first place. I'm gonna prepare a 0. So now I'm going to take out the tuples. It's gonna be the start, add, time, and profit. So it will be the jobs I-1 because I will take the first job. This is a fi to 1 to n plus 1. This is for the DP array. Yeah. But here for the first job, because I've already plus a 1, as you can see, it is starting from 1 to n plus 1. It means I've already plus 1. But for the actual job, actually, I need to use I minus 1 because this is the first job. For example, I equal to 1, I minus 1, it is a 0. This is the first job. Now, I'm gonna use a binary search. So I'm gonna use the bisect right. Let me explain again about why I'm gonna use the bisect right, not left. Yeah. Let me first finish writing it and then explain it. So yeah, for this one, I'm gonna search for the jobs and I'm gonna check the start place. So here actually, yeah, the first place is add time and then it is the start time because I prepared it like this. Now I'm going to check the start time. Yeah, but this is a tuple inside. I'm not sure if there will be any influence for this start time because for the binary search, if this is a tuple for the binary search, I have to keep two positions. Otherwise, I have to keep the first position will be the start time and the second position I will give an infinite. Otherwise, I cannot get the right result. So this means I've always check for the first position. So I've always check the first position as the add time. So inside the add time array, I'm gonna find this s. So this s is just a start time. Now I will update the let me first let me update the DP array first and then explain why I will use this line. Yeah. So for the fi, it would be equal to, if I didn't take it, it would be the maximum. If I didn't take it at this position, it's gonna be fi minus 1. And then it's gonna be the profit. Yeah, I will have a profit and where is the add time? Because I'm going to use this start time to find the add time. Actually, the add time is just fc. Yeah. Now, let me explain these two lines. Yeah, because according to the DP array you defined, you may have different bisect right or different fi, but it's gonna be very similar. Let me first explain why I'm gonna use the bisect right. Yeah, so according to this drawing, this is a for example, in this example we have a 100. If we take this 100, it means we're gonna in this array, in this sorted array, according to the add type, we're gonna find this E1. If we're gonna find this E1, we have to use a bisect right, because for example, this is S4, we're gonna find some E which is more than this S4, so this is E2, it is more than S4. After we find this E2, we're gonna use minus 1 to find the E1. Now we can find this E1. Yeah. But what if this start time is at this position? It is here. I mean this S4 is equal to this E2. What's gonna happen? So if I use bisect right, yeah, if it is equal, if I use bisect right, what position I will be? I will be at this position because bisect right will not be at the same position when it is equal. It will always be the next position. I will be at E3, but E3 at this position will be minus 1, and then I will be shifted to E2. It means I still will use this E2 because it is at the same line. But what if it is left? If it is bisect left, this is S4 and this is E2, E2 equals to S4, but I want to find a place. Yeah, but I want to find a place which is more than and equal to this E2, but it will be the same position. If I use a bisect left, it will be at this position. If I use a minus 1, it will be E1. If it is at E1, of course it will be wrong because it must be E2. Yeah, because here it is at the same position. I can take this 100 and then I'm gonna use E2. Yeah, but if I use a bisect left, I will use E1. So this is why I'm gonna use a bisect right. Yeah. Now let me explain why I will use FC. Yeah, because basically for this problem, this is the z I find the place. I should use this z minus 1. Yeah, but for my DP array, I've already plus a 1 because the first place I've keep a 0 and then plus 1. So this means from the beginning, if it is fz minus 1, I need to plus a 1 because for the DP array, for this F array, I've already plus 1 because I started as a 0. This 0 is just a dummy position. Yeah, it didn't mean anything. It is just easy for the calculation, as you can see. It is I minus 1. Yeah. So fj minus 1 plus 1, it should be fj. Yeah. So here, I don't need to use a minus 1. So this is why directly I can use a j, and here should be p plus fj. So finally, I need to return the result. Yeah. Now let me just check it if it works. What is wrong? Yeah, I need to zip it because I need to, yeah, let me just zip it inside. Yeah, because this is just a tuple, I need to zip it and then sort it. I need to zip add time, start time, and profit inside and then sort it. Now I will have an array. Inside array, it will be the add time, start time, and profit tuples. Yeah, and now I can use the DP array to solve the problem. Yeah, now let me run it. Yeah, as you can see, it works. Now let me submit first and then analyze the time complexity. As you can see, it works and it's pretty fast. So the time complexity, this is n, and this is a bisect. So this is a log n because it is a bisect right. So the time complexity will be n log n. So this is why you have to use the sorting first and then the DP to solve the problem. And you should not use the DP as as the continuous array of all the time, like from 1 to 10 to the power of 9. You have to use the separate time. I mean, yeah, it is not a continuous time. You have to use the time which is not continuous. So this means you have to use the jobs array, and the jobs array is just a tuple. Thank you for